Hello and welcome to part 55. In this video, we will learn about generics. Generics in C# is a way to create code that can be used with different data types. We can create generic classes. We can also create generic methods. When we are creating generics, we normally use these angular brackets. In C#, generics is used at many places. There are a lot of useful classes that are available in C# that can be used by developers to make their code more readable. The most popular one is list. List can be used to store a collection of items. Let's go to Visual Studio and understand what is a list. Let's create a list object first. If you notice here, when I type list, the IntelliSense is giving me the option or the suggestion to put these angular brackets. Angular brackets mean I can specify the data type, meaning which type of item I want to store in my list. If I want to store integers in my list, I can specify integer here. Let's call it numbers. And now I can store numbers in my list like this. I can use the add method and add the integer like this. So list is a generic class which is inbuilt in C#. Let's go to implementation of this class and see how it was created. If I right click on this and select go to implementation, the list class will get opened up and we can see in the definition of list class, we have used these angular brackets, and within these angular brackets, we have provided the T here. T means the type. So this is how we can create generic classes. Similarly, we can see the generic methods also here. So this is one of the generic method that we have used in our program, meaning when we are calling add method, we have passed 12 here. But if you see the implementation of add method, it is a generic method, so it can take any data type, right? But because we have declared the list object with integer here, this list is now type safe. We cannot add any other data type here. Like if I say nums dot add, if I try to add a string here, we will get the compilation error. You can see here, cannot convert from string to integer. So when we're using the generic classes, it will provide the type safety also. And I have created the list here of integer type, but we can create list of any type. Like I can provide string here. So using generics, we can use the same classes, meaning we are using the list class with different data types. This is the flexibility that is provided by generics in C#. So let's go ahead and try to understand generics with some custom code. Let me create a class. Right. So I have a very simple class with the name tool. This class has one method is equal, and currently it is taking two parameters, integer a and integer b, and it is checking if these integers are equal or not. If they are equal, we are returning true. If they are not equal, we will be returning false. Let's try to invoke this method and see if it is working or not. So first of all, let's create a reference of tool class. And because the is equal method is declared as static, so we don't have to create objects of this class. We can directly invoke is equal method. Now let's pass 4 and 5. And let's store the result, whatever is coming from this method, in a bool variable. Let's call it result. And finally, let's print the result. And run the program. You will notice we are receiving the false here because we have passed 4 and 5. Okay, so our program is working. But now let's say a requirement is you want to compare strings also with this method. You want to compare floats also with this method. In normal case, this will not be possible. If I try to pass a string to our is equal to method, this will give us the compilation error because is equal method cannot deal with string data type, because the parameter is marked as integer. One solution can be, instead of using integer data type, we can use object data type. And we can pass string here, ABC. And if I run the program, this will work fine. We are getting true. So this method now can work with integer also. Let's say result2, and this time instead of passing string, let's pass integer 1 and 1 and print the result 2 now. And if I run the program, we will receive false here because we cannot compare two objects with equal to operator. For that, we need to use a dot equals method and pass the second object in this. Now if I try to run the program, you will see we are receiving the true result here. Now we are able to compare strings and numbers using only one method, is equal. So now is equal is supporting all the data types that are available in C#. But this is not the correct way to do it. Using objects should be the last option that you should be doing while writing the code, because when you are passing string to a method that is expecting an object data type, what will be happening here? The string data type will be casted to object type, and this is very expensive operation, meaning it will take a lot of time to convert or the typecast the string to object type. This is called boxing and unboxing. We will understand the concepts of boxing and unboxing in our upcoming videos. But for now, we can understand this is not the correct way to handle these kind of scenarios. Because let's say if I try to pass the second object as ABC, we will not receive any compilation error because the data type is object. Even if I pass any data type, this will not give the compilation error. If I try to run this application now, it will again run, but currently we are comparing 1 with ABC. We should not be allowing this in our program. Now the program is not type safe, right? To make our program type safe, we can use generics. So let's go ahead and try to create this is equal method, a generic method, so that we can work with multiple data types. Let's remove this code for now. Instead of mentioning the data type directly here, what we can do, we can just mention T here. T means type. This is not mandatory. We can even give some other alphabet also. And once that is done, we have to provide that alphabet in the angle brackets like this. Let's change it to T. Now let's see how we can invoke this generic method. Let's create a variable of Boolean type and call it result equal to tool dot is equal method, and within this I need to specify the data type which I will be passing to my parameters. If I specify string here, meaning the generic method is equal will be used with string data type. Now I can pass only string to my parameters. You will notice here when I hover over is equal method, it will say string and it is expecting string parameters. Now our method is type safe. If I try to pass some numbers here, let's say some random number, we will receive the compilation error. It will say cannot convert integer to string type. If I pass XYZ here and let's print the result just to test if our method is working properly or not, and run the application, we will receive false. And if I give the proper string here ABC and run the program, we will receive true. So our is equal method is working perfectly with string data type. But the beauty of generic methods is we can change the data type according to our requirement. Let's suppose I want to compare two integers. Now I can change the string here in the angle brackets to integer. Now it will expect integer parameters. Let's pass 4 and 5 and run the application. We will get the proper result. I can change this data type to anything which I want. I can change it to Boolean. Then it will expect Boolean data type as parameters, right? So the point that I'm trying to make here is if our method is generic, it can handle any data type. Similar to methods, we can have generic classes also. Let's understand this also with an example. Let's remove this method for now. And to create a class generic, we have to use angle brackets again. And we have to pass T here. Once we have declared T, Now we can use this t type like as any other data type. Like I can create fields using this type. So I can say t underscore data like this, and I can create a method. Let's change this data type from static to the instance field so we can understand how we can create objects of classes which are generic. So we have a get method and we have the set methods, and if you notice in our class we have not specified any data type here. Our class is independent of the data type. How we will create objects of generic class? It is very simple. When you are creating the object of the class, I can pass the data type when creating the object. I will pass string here. Let's say equal to new tool string. Right? Now the object is created and we can simply go ahead and set the data. Let's pass hello world. All right. Once data is set, we can again call our get method to get the data, and let's store the result in a string variable, and at the end print the result. Let's run the program. You will notice we are receiving hello world message. So this is how you can use your generic class in your program. Now if I want to make use of integer data type in my tool class, I can just change the data type here to integer. And because now set is expecting t data and t is now integer, we should be passing numbers here. We cannot pass string because you can see the compilation error cannot convert string to integer. So we should be passing integer here. And again, we cannot store get result in a string variable because if you see the return type of get is t and t is now integer. So we should be having an integer variable. And if we run the program, you will notice we are receiving 45 here. So guys, this is how you can use generic classes and generic methods in C#. Okay, so these are some of the other generic data types which are inbuilt in C#, which are collections, dictionary, queue, stack, and list. In the future videos, we will understand all these data types of C# in detail. To summarize, here are the benefits of using generics in C#. Versatile. If we use generic in our code, this will make our code more versatile, meaning it can be used with different data types, which makes it more reusable. When we write generic code, it is more concise than writing the non-generic code, meaning we don't have to write different methods for different data type. Generic code will improve the performance of your code because there is no need of typecasts, meaning there is no need of doing boxing and unboxing. When we write generic code, this will make our code type safe and it will ensure we are using the correct data types. So guys, this was all about generics. In the next video, we will learn about toString method.